Hi, in our last video, we talked about the basic concept of Carl-Pearson's coefficient of correlation. That what exactly is it? Today in this video, we'll talk about how to compute the correlation coefficient using the given data. So let us first talk about the basic formulas that we are going to use. So let's consider two variables, x and y. Now we know the correlation coefficient, which is represented by R, is equal to covariance of xy upon square root of variance of x into square root of variance of y. Or we can also say it as covariance between x and y upon standard deviation of x into standard deviation of y. Right? This we have already seen in the previous video. Now, let's suppose x observe the values x1, x2, x3 till xn, and similarly y observe the values y1, y2, y3 till yn, right? So now we know the covariance between x and y is equal to 1 upon n summation x minus x bar into y minus y bar, right? So this we have already seen previously also in our previous videos. This can also be written as 1 upon n summation small xy, where small x is equal to x minus x bar and small y is equal to y minus y bar. We also have another formula for covariance between x and y, or we can also write it as or summation xy upon n minus summation x upon n into summation y upon n. I'm just giving you different formulas that we are going to use later, right? Or we can also write it as summation xy upon n minus x bar into y bar, right? Because summation x upon n is nothing other than x bar, and summation y upon n is nothing other than y bar, right? Because this is generally the mean, right? So we have these formulas for covariances. Similarly, we have different formula for variance also, right? Variance of x, if I want to write, so what is variance of x? It is simply 1 upon n summation of x minus x bar square. Yes, right. So we have another formula also for the variance, that is, this is also equal to summation of x square upon n minus summation x upon n whole square. This also we have known, we have already studied about variance very deeply in our earlier videos. Or we can also say this is summation x square upon n minus x bar square. Yes or no? So these are different formulas for variance of x. Similarly, we have formulas for variance of y. So let us just write it down. So variance of y, since we have already seen the variance of x, so we know we can simply copy it down from here. The variance of x can be written as like we can write variance of y in the similar terms, just we need to change x to y, right? Okay, so let's just write it down entirely from here. We'll write it over here. This is the variance of y. Now we'll see simply the correlation coefficient. So let this be denoted as 1. So now substituting the values in 1, let's write out the first formula. Substituting values in 1. Right, so in 1, that is R is equal to covariance of xy upon square root of variance of x into square root of variance of y. We'll put the values over here. Now let's see. So covariance, let's first of all, we will consider this formula. So let's just write it down. This is equal to 1 upon n summation x minus x bar into y minus y bar upon square root of 1 upon n summation x minus x bar square into 1 upon n summation y minus y bar square, right? So this is 1. Now what if we cancel out these n's? If I want to simply cancel out this n, can I say, so this is square root of 1 by n, 1 over here and 1 square root. So if 1 by n, we take this out from here, and from here we can take this whole 1 by n out. So can we write cancelling this n with these two n's since it's in multiplication? So this becomes summation x minus x bar into y minus y bar upon square root of summation x minus x bar square into summation y minus y bar square, right? So can we write this out? Now this can also be written as summation xy, small xy, upon square root of summation x square into summation y square, where let's just write it like this, where small xy, right, small x is simply equal to x minus x bar and small y is equal to y minus y bar, right? So this is our formula. Let's name this formula as 2, right? So this is another formula 2. So we can always use this formula, or we can always use this formula. Either way we can say let's name this as 2. So we can use this equation also, right? Similarly, we generally have more equations to work upon it. Let's move on to a more simplified version. So now substituting, now let's take another r. If instead of taking these values like the covariance, this formula, what if I simply take covariance as, let's suppose, if I take in covariance this one, let's substitute this value. And since we are taking xy, we are not subtracting x minus x bar. So again, we can take variance formula also from here. What if we take this covariance and this variance? So how will the formula change? Let's just write it down. So this r is equal to summation xy upon n minus summation x upon n into summation y upon n, right? Covariance formula, this is same. This and this variance formula we will use, that is square root of summation x square by n minus summation x by n square, right? See this formula, into summation y square upon n minus summation y upon n whole square. So this formula, what if we use this? So if we can write it like this over here. So this r is equal to, from here, what if I take out, what if I multiply numerator as well as denominator with n square? So write it down. Multiplying numerator and denominator by n square. So yeah, so we will write that like this. So then r is equal to, from here multiplying it. So this is n now. Multiplying by n square means summation xy is left, n into summation xy, right? So this is n into summation xy minus this n square cancels with this and this n cancels. So this becomes minus summation x into summation y. This upon, again we are dividing, multiplying and dividing by n square, right? So this becomes, when we are doing it by n square, what can we do over here? So n square multiplying means, let's suppose we are taking one, since it's a square root, so we can take two n squares, one n square over here and one n square inside this, right? Because this is a square root. So n to the, when we are taking it inside the square root, n square becomes n to the power 4, right? So n to the power 4 square root means n square. So we'll simply take it over here. So this becomes, from here, it becomes square root of n summation x square minus summation x square, summation x whole square into similarly n summation y square minus summation y. So this becomes our equation number 3. So this is the most used equation. But sometimes what happens is we have a data which is quite high in values, right? So in that case, what will we do? We have large number of values and those values are quite high. So it becomes difficult to square them up. So to understand this, we know that let us take a variable u such that u is equal to x minus a upon h, and another variable v such that v is equal to y minus b upon k, where a and b are arbitrary constants, means this can be negative as well as positive, and h and k are positive constants, right? So these are positive, and a and b are arbitrary constants because a and b can be negative as well as positive. Now we also know that if h and k are positive constants, that is the constants that are impacting the change in scale are positive, right? So it is independent of change in scale and origin whenever our constants that are changing the scale are positive. These are independent of change in scale. Therefore, r is equal to the correlation coefficient of xy is same as the correlation coefficient of uv, right? So we can also write it like this, that r is equal to summation uv minus, or simply n into summation uv minus summation u into summation v. So basically I'm simply in this formula we are simply substituting u instead of x and v in place of y, right? So this becomes square root of n summation x square minus summation x square, this into n, instead of n we need to write u, x we need to write u and v. So let's just write it down, u square, and this becomes into n into summation y v square minus summation v whole square. Now this is our formula number 4, or this can also be written as like this, summation uv minus summation u summation v upon n upon square root of summation u square minus summation u upon n square, this into another square root of summation v square minus summation v upon n square. So this is also an equation, right? So now let's see, from where did this come up? From here, right? So basically throughout this we have taken out 2 to 3 different formulas. Let me just highlight the main formulas that we use. So yeah, so one formula is simply this, right? Then second formula that we use is this, and the third formula that we use can be either of these two, right? So this is how we complete. Now some of you might not have understood the derivations, that how did we come up to this. So just try to write it down by yourself on a pen and paper, and then you will understand what I'm trying to do over here, right? Also I've attached cards over there, so you can just see from where what formula we have actually taken up. Okay, so now let's talk about questions. So example, calculate Carl Pearson's coefficient of correlation between the variable x and y using the following data. Now we have been given data and we need to find the coefficient of correlation. So in this, we'll be doing it using two formulas. So one, I'll use formula number 2, right? What was that formula? This one. Summation xy upon, so r is equal to summation small xy upon this summation into summation x square into summation y square, where small x is equal to x minus x bar and small y is equal to y minus y bar. Right? So one, we will use this formula, and alternatively, what other formula we'll use? Let's use formula number, this one. We will another formula that we'll use is this one. Right? Why I am using this formula? See, basically this formula and this formula are same, but the question has different values, right? So some are big, some are small, so it will be more easier. It's always easier to use this formula. So this formula that we use is n into summation uv minus summation u into summation v upon square root of n into summation u square minus summation u whole square into square root of n summation v square minus summation v whole square. So these two formula we will use, right? I've just simply copied down the formula. So let's start with our first formula. First we'll talk about this, right? Okay. So let's start. We are given x and y. Now for this, the formula that we will use, we have already discussed it, that r is equal to summation xy upon square root of summation x square into summation y square. This is the formula that we'll use. So for this, what all things we need? We have x. Next we need is x minus x bar. We need is y minus y bar, right? This is equal to small x and this is equal to small y. Once we have this, then what do we need? We need x square. So small x square, then we need is y square, and then we need is x into y, right? So let's see. First of all, for that we need x bar. What is x bar? X bar we all know is simply equal to, x bar is equal to summation x upon n. So for that we need summation x. So let's sum it up. 25 plus 40 plus 30 plus 25 plus 10 plus 5 plus 10 plus 15 plus 30 plus 20 summation x. This is equal to 210, right? 210. You can just calculate alongside. Now we this becomes 210. What is the number of n? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 observations. So x bar becomes 21. Similarly, y bar is equal to summation y upon n. Now y, summation y, what is summation y? Summation y is 10 plus 25 plus 40 plus 15 plus 20 plus 40 plus 28 plus 22 plus 15 plus 5. This is equal to 220, 210, 220. So now this becomes 220 upon 10, which is equal to simply 22. We have x bar, we have y bar. Now we need is x minus x bar. So that is 25 minus 21, right? So 25 minus 21, 40 minus 21 is 19, 30 minus 21 is 9, 25 minus 21 is 4, 10 minus 21 is minus 11, 5 minus 21 is minus 16, minus 11, then it becomes minus 6, 9, and 20 minus 21 is minus 1. Similarly, we need y minus y bar. Let's first complete the table. So y minus y bar means all the observations of y minus 22. Right? So 10 minus 22 minus 12. 25 minus 22 3. 40 minus 22 18. 15 minus 22 minus 7 minus 2. 18 6 0. 15 minus 22 minus 7. 5 minus 22 is 7 minus 17. Right? So now we need is x square. X square is 16. 19 square is 361. 9 square is 81. 4 square is 16. 11 square is 121. 16 square is 256. Minus 11 square is 121. 6 square is 36, 9 square is 81, 1 square is 1. Then we need is y square. So y is the small y. So now we are just squaring it up. 12 into 12 is 144. 3 into 3, 9. 18 into 18 is 324. 7 square is 49. This becomes 4. 18 square, 324. Then 6 square, 36. 0, 49 and 289. Then we have a small x into small y. Means we need to multiply this and this. So small x into small y. Minus 12 into 4 is minus 48. 19 into 3 is 57. 9 into 18 is 162. Then 4 into minus 7 minus 28. This becomes 22. Minus 288. Minus 66. 0. Minus 63 and 17. Now, so r is equal to summation xy upon square root of summation x square into summation y square. Let's simply just take out what all. We need summation of xy. So xy means we need to sum this up. Minus 48 plus 57 plus 162 minus 28 plus 22 minus 288 minus 66 plus 0 minus 63 plus 17. So summation xy is equal to minus 235. So I've already calculated these values which I'm writing over here. Right? So this upon square root of summation x square. We need summation of x square means we need to sum up this particular column. So now 16 plus 361 plus 81 plus 16 plus 121 plus 256 plus 121 plus 36 plus 81 plus 1. This becomes summation x square is equal to 1090. I'm just putting it over here 1090 multiplied by summation y square. So this summing this entire row up, we'll get this as 1228. This becomes 1228. Now this becomes minus 235 upon, so square root of 1090 is approximately 33. This into approximately 35. So let's just write it out 35 approximate value. So this becomes minus 0.203 approximately. So this was the first formula we used. Right. So now we'll move on to our second formula. This from here. Right. So we'll just write out the formula first. What all we need is r is equal to, let's just write now, r is equal to n summation uv minus summation u into summation v upon square root of n summation u square minus summation u whole square. This into square root of n summation of v square minus summation v square. So we have this, right? So okay, so first of all we need to calculate u, then we need to calculate v, then another thing we need is u square, then we need is v square, and then we also need is u into v. So this formula, right? So what is u? Where we know, we are just writing out formula, calculations we'll do above, where u is equal to x minus a upon h, right? And v is equal to y minus b upon k. So now in this case, let us assume that let's take h and k as 1 each, right? Because it will be easy. See, had it been 250, 400, 300, 25, 250, 100, 50, all those series, we would have simply taken it as, we would have taken our h as 10 just to cancel out all the 10s over there, right? But since already numbers are such, we don't require any h or k. We can simply assume h and k as 1. So h is equal to 1, k is equal to 1. So it does not impact. And let a is equal to, so out of these value, what do you think? What a should we take? Let us take a is equal to 20 because, you know, subtracting zeros at the end is very easy. and b is also equal to 20, because from this data we can easily take 20, and it's quite easy to subtract something ending with 0. So now u, what is u? U is simply x minus a, that is 25 minus 20. So that becomes 25 minus 20 is 5. Yeah. 40 minus 20, 20, 30, 30 minus 20 is 10, 25 minus 20 is 5, 10 minus 20 is minus 10, 5 minus 20 is minus 15, 10 minus 20 is minus 10, 15 minus 20 is minus 5, 30 minus 20 is 10, and 20 minus 20 is 0. So it's quite easy now when we have simply subtracted it using 2, 0, 20, right? Alright. So now next, let's find out v. V is again y minus b, right? So v is equal to y minus b. So now y minus 20. So now 10 minus 20 is minus 10. 25 minus 20 is 5. 40 minus 20 is 20. 15 minus 20 is minus 5, 20 minus 20 is 0, 40 minus 20 is 20, 28 minus 20 is 8, 22 minus 20 is 2, and 15 minus 20 is minus 15, 5 minus 5 and minus 5. And 5 minus 20 is minus 15, right? So we have all these values. Now next we need is u square. So let's square it up. 5 into 5 is 25, 400, 100, 25, 100, 2 to 5, 100, 25, 100, 0. Squaring was also quite easy when we simply had to just do this, right? Now we need is v square, so we need to square this row. So this becomes 100, 25, 400, 25, 0, 400, 64, 4, 25, 225. Right? So we have this. Then what we need to do is we need to find u into v. Right? Okay. So u into v means multiplying this and this. Okay. So 5 into minus 10 becomes minus 50. 20 into 5 is 100. 20 into 10 is 200. 5 into minus 5 is minus 25. This becomes 0. 15 minus 15 into 20 is minus 300. Minus 10 into 8 is minus 80. Minus 5 into 2 is minus 10. 10 into minus 5 is minus 50. This becomes 0. Right? You can just check this up. Okay. So after this, we need to find, in this formula we need summation uv. We need to sum this up. What will be the total of uv? It becomes minus 215. I've already done this calculation with me. We also need summation u square and summation u. Similarly, we need summation v square and summation v. So we need to just add these up. So summation of u becomes 10. Summation of v is 20. Summation of u square is 1100. And summation of v square is 1268. You can always do this. In our graduation, generally we have calculators to sum them up. Otherwise, we can also simply add them up and solve it. Right? So now let's just simply put it in the formula. R is equal to n. What is n? N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 observations. 10 multiplied by summation uv. Summation uv is minus 215 minus summation u into summation v. Summation u is 10 multiplied by summation v is 20. Right? This upon square root of n is 10 multiplied by summation u square. Summation u square is 1100 minus summation u. Summation u is 10 square. Right? So this into, again n is 10 into, from here we are using this formula. Let me just mark it up in another color. From here we are using this formula. Right? Okay, 10 into summation v square. Summation v square is 1268 minus summation v. Summation v is 20 square. 20 square. Right? So we have simply just substituted the values. Now this becomes minus 2150 minus 200. This upon, now 10 into 1100 is 11,000, square root of 11,000 minus 100. This multiplied by square root of 12680 minus 400. Right? So this becomes minus 2350 upon square root of 10900 multiplied by square root of 12280. Now this becomes minus 2350 and square root of. So this is approximately 104.4 and this is approximately square root of 12280 is approximately square 110.81. So now doing this, we get is minus 0.203 approximately. Right? So now we can see the answer is same whether we use this method or we use this method. So now it depends upon the data which one formula you want to use, and also according to your convenience. This formula is also known as, the last formula that we did is also known as step deviation method, right? So see, somehow when the values are small, it sometimes becomes easier to solve this method because we need to multiply, divide smaller things. But when the values are quite large, it's more easier to use this formula, the last one, right? So this is how we find the correlation coefficient. In our next video, we will talk about correct correlation, how to find a correct correlation given that we have made some errors while writing down the data or while calculating. So in that case, how to get the correct correlation coefficient, right? So that will be our next video, and after that we'll be talking about bivariate correlation. I hope you like this video. Do subscribe this channel for more videos. Thank you.